Okay, in this video I want to do another integration by substitution. I've shown you how to the basics of it in a separate video. This one is a little bit trickier. Alright, so I'm going to work through this pretty quickly here and pause the video along the way if you don't understand something and need to work it out yourself. What we're going to do here in this problem is we're going to let u, alright, our variable for substitution, and again that can be any variable you want, p, an m, whatever you want, but we're going to let u equal the stuff inside of this square root down here in the denominator, which is 1 minus 6x to the third. Okay, that's what we're going to let u equal. So when we're done, we're going to substitute in place of this, what I'm circling in red here, we're going to substitute in the letter u. Okay. One other thing that I'm going to invoke here, you can do this now or you can do this later, but do you see this 2 right here? That's just a constant. And if you haven't learned this yet in calculus, when you're doing an integral and you see a constant, any constant, what we call a constant multiple, can actually just come completely out of the integrand, the integral symbol there, and just be kicked out front. So what I'm going to do is I'm going to bring that 2 out front. And I'm going to do that in just a second, okay? But keep that in mind. We're going to move that 2 out front. In fact, you know what? I'll do it right now. Let me write this as, alright, the integral times 2. There's my 2 out front. So now I've got an x squared over the square root of 1 minus 6x to the third dx. Okay, so maybe I should do that now. Just bring the 2 completely out front since it's a constant multiple. Alright, now back to this. If u is equal to this, let's find the derivative of u. Alright, let's find du with respect to x. Hey, that's no problem. That's just, well, that's a constant, so the derivative of 1 is 0. And so from this right here, we have the derivative of that is a negative 18x squared, right? Okay, well, there's one more thing I'm going to do as far as this is concerned, as well as let's get that du by itself. So I'm going to multiply both sides by dx. All right, multiply both sides by dx, and I hope you see that du is equal to a negative 18x squared dx. Well, as I look back at the original problem, I don't see a negative 18x squared dx. I do see, let me take away the negative 18 for a second, I do see an x squared dx, right? That I do see. Look, it's right here, x squared dx. There it is. But I don't see a negative 18 in front of it. So I'm going to do this other trick here, and that is let's divide both sides by negative 18. Right, of this problem, of this equation over here. If I do that, notice the negative 18s are gone over here, and I'm left with x squared dx is equal to negative du over 18, or you can put the negative with the 18 on the bottom, it doesn't matter. Okay, so in place of x squared dx, right, what I'm circling in blue here, in place of this little bubble, I'm going to stick this in, right, because anywhere I see an x squared dx, I'm just going to replace it with negative du over 18. In place of this, the thing inside of the square root, this stuff, right, that's all of this right here, I'm going to replace that with a u. Right, we can do that. So let's use our substitution rule here, right? This is all integration by substitution anyway, so here goes. I've got a 2 out front, and it's the integral of, and again, in place of this bubble, I'm putting in a negative du all over 18. Hope that makes sense. Alright, that's just this thing right here. And I also have, maybe I didn't leave enough room for myself, I also have in the denominator the square root of u. And nothing is left in the numerator, so I'm just going to write it as a 1. Okay, do you see then that I have another constant multiple? I have a negative 1 over 18 that, just like this 2 that I pulled all the way out, I can pull this all the way out as well. So what I have out front now is, let's clean this up a little bit. So this guy's right here, I'm going to move completely outside of the integrand, right, the integral there. And out front now I have a negative 2 over 18 integral of 1 over square root u du. So far so good. Again, pause this video if I'm losing you along the way, okay? Hey, let's clean this thing up front. That's really just a negative 1 over 9, right? And if you want, you can rewrite this 1 over square root of u, since the square root can be written as an exponent of 1/2 and it's in the denominator. I can write all of this way. Instead, I can write a negative 1 over 9 out front. That's simplifying this fraction. Integral of u to the negative 1/2 du. Alright, so that looks a little bit more manageable, okay? And now, invoking our rules for antiderivatives here for integration, we're simply going to add 1 to this exponent here, which now gives us a positive 1/2, and that positive 1/2 moves to the denominator, right? It goes there as well. Alright, I'm running out of room on this paper, so let me scoot over here. Here's what I have. I have negative 1/9, right? And then my new antiderivative is u to the 1/2 all over 1/2. And again, since this is an indefinite integral, don't forget your plus c hanging out here at the very end. Alright, look, I've got stuff divided by 1/2, right? I have stuff divided by 1/2. You know the rule for dividing fractions is to flip and multiply. Right? Flip and multiply. So I'm flipping this 1/2 into 2 times 1. I'm going to multiply it by that stuff. So if I want to rewrite this, I could rewrite this as negative 1 over 9, 2, right? I'm flipping this denominator here of 1/2, flipping it, u to the 1/2 plus c. And I hope you see that, look, I can multiply these two things together and just come up with negative 2/9 u to the 1/2. Instead of writing it as u to the 1/2, I'll write it as the square root of u plus c. Okay, I'm almost done. Almost done. Last thing is, I don't want this answer with respect to u. I want this answer with respect to x. So let's put back in place of u what we substituted it out originally as 1 minus 6x to the third. Okay, well, we can do that. My final answer then is going to be a negative 2/9. Inside of the square root, I'm going to have 1 minus 6x to the third, because that's what u is actually equal to, and then plus c. Final answer. Isn't that pretty cool? That's a lot of work, a lot of room for mistake, but take your time through it and see how that works out for you. I hope that helps.